All right, so arcs, chords, and diameters. This first picture, what I'm showing you, again, I've got two separate chords that are in there. Hopefully you can see that I made this little notch here. If these chords are the exact same length, that means the arcs on the outside are the same length. Bless you. Likewise, if the arcs on the outside are the same length, that means the inside chords are going to be the exact same length. Make sense? Okay, I'll start off with a picture. I got this necklace right here. It's telling me that in this necklace, MJ, that's a little, so it's an arc or a chord there. MJ is the exact same length as KL. I don't know if you can see that very well. I'll draw it in for you. But that's what that picture is showing you. All right, so if both of those chords are the exact same length, and they tell me that KL is 90, my job is to find the arc for JM. Okay, if one side is 90, what's the other side going to be? 90. And it's just that easy. Yep. That one, yeah. Ready for the next one? I'm going to make it a smidgen harder. Again, smidgen harder. What's that? Yeah. Yeah, so again, we've done this stuff like a couple chapters ago, but we're just kind of coming back to it. And this time we're using a circle instead of a triangle. All right, so for this circle, arc, RS, is the exact same length as arc, TB. So if these are both the exact same arcs, that means that both of those chords are going to be the exact same length. So I can set them equal to each other. So I get 5x minus 9 equals 2x plus 3. Now it's an algebra problem, and we can do that. We're just going to solve for x, so plus 9 to both sides. I got 5x equals 2x plus 12 minus 2x to both sides. I get 3x equals 12. Divide both sides by 3. I get x equals 4. I'm not done yet because it's asking me, what is the length of RS? So if I know what x equals, and they tell me this formula, what's the very last thing? Plug it in. So I get 5 times 4 minus 9. 5 times 4 is 20 minus 9. That tells me that RS is going to equal 11. Little reminders with symbols. If it has this little thing, it means it's an arc. If it's the outside part. If it's a straight line, it means it's going to be the core of the line segment. So far, so good? Show me. There it is. Again, it's two separate circles, but even though it's two separate circles, this arc and this arc are the same length. So if they're the same length, the chords are the same length. I want you to solve for YZ. And I'll come around and check it. Yes, sir. Yes, sir. That's it. ma'am. Yep. Yes, ma'am. Yes, sir. This one here should have been a 2x. So it should have been. That should equal 4. Yep. All right, based on what I saw, you guys all set it up the correct way. You had 7x minus 2. That equaled 5x plus 6. Should have ended up with x equaling 4. And then once you plugged it back in, your length for yz should have been 26. Thumbs up, thumbs down. How you feeling? Super duper. Okay. Again, I'm just going to show you the picture that I combine all this stuff together for you. This circle, I've got a diameter or a radius that is going to have a chord that cuts it perfectly perpendicular. Okay? So again, I got the radius, I've got a chord, and that's the perpendicular side. Radius or diameter. Either way, as long as it goes from the central point to the outside. So this one shows a diameter that cuts straight through it. Nope, just the lines. Okay, so again, if I have the part that goes from the central point to the outside, so either radius or diameter, and this one's perpendicular, what it does with this chord is it bisects this chord perfectly. That means that like CO and OB are going to be the exact same length. Cut perfectly in half. Okay? Because it cuts that chord perfectly in half, it's also going to cut this arc perfectly in half as well. Meaning this part of the arc and this part of the arc are going to be the exact same length. Make sense? All right, example 1. Here, I'll just zoom in so you can see it. Here's what my circle looks like. But if you want to draw the picture, you can. All right, so this picture says from P to R, PQR, this arc, that whole entire thing is 98. So if I wanted to find out the length of QR, what would I do? Blaney? Divided by 2. So QR is 49 because all you did was 98 divided by 2. Okay? This part of the circle saying TR from here to here is 6. So if I wanted to find the length of PR, so PR is going to be this whole entire length from here to here. How long is that? Okay? Yeah, you just took 6 times 2. That's all this part is. Make sense? Divide by 2, multiply by 2, or set them equal to each other. I'll give you one practice. Actually, you know what? Yeah, we'll just do this quick without even writing it down. All right. So DEF, this whole entire angle is 150. What would this part be? 75, you just divide it by 2. That's it. I'm not going to give a bunch of practice problems for this part because I think you guys got it. Okay. The very last diagram. Again, you can set things equal to each other. That's really all this lesson is. I'll erase some of my lines so I'll redraw them for you. Okay. All right, on this picture here, what it's telling me, again, I've got all this stuff going on. I've got this line that's coming off of the center, and it's making a perpendicular line. What it tells me is that the length of this line and this line, if these two are the exact same length, then this side and this side for the whole entire chord will be the exact same length. Again, it's the exact same distance, it's perpendicular. That means this whole entire chord and this chord will be the exact same length. If those are the exact same length, then the chords on the outside, or sorry, the arcs on the outside will be the exact same length. Now I'm not going to draw because there's going to be way too many lines. But if it's perpendicular, the two sides of that are kind of exactly matched, just like the previous example. Make sense? All right. Example number 1. In this circle, I've got QP being a chord, RS is a chord, HU and HT are coming out to make a perfect perpendicular line. Excuse me. All right, taking the information they gave me on the top, they said that RS, this line segment here, is 14. They said that QP, that line segment here, I'm just going to write it down here, is 3x minus 4. What can you tell me about this chord and this chord? They're equal. So I just set them equal to each other. So if I wanted to find the value of x, I would just take 3x minus 4 equals 14. And I just got to do algebra. So plus 4 to both sides. I get 3x equals 18. Divide both sides by 3. Finally, x equals 6. So good? It's not on there for a question. How long is US? Half of that number. So it's 7. So if this length is 7 right here, I'm going to show you one extra spot because you will see something like this a little bit later. So I've got this length from H to U is going to be 8. R to U is going to be 7. If I wanted to find the radius, again, going from the center all the way to the outside. What does that shape look like? A triangle. It's a right triangle. If I wanted to find the radius, how can I do it? I've got one side, I got one leg, I got the other leg. Pythagorean's theorem. If I wanted to find the radius, and again, I knew two of those sides, either the radius, or I knew a leg, or I knew this part, I could use Pythagorean's theorem to figure out that other missing part. So I could do that by saying c squared, because that's the one I don't know, equals 8 squared plus 7 squared. That gives me 64 plus 49 equals c squared. So c squared equals 103. I'll square root both sides. So my radius, my c, is going to equal, was like 10.6. Yeah, 10.6. Because again, I had to square root both sides. So if they give you two of the legs, you can use Pythagorean's theorem to figure out the last one. Just want to visually show you that one. This one, your time to do it on your own. Show me you can get this one. I want to find the measure of PQ. So you'll have to solve for x, and then you have to plug it back in. That's it. That's all I want from you today.
Is 4x minus 3 supposed to be EF or is it supposed to be EQ?
That's the QP.
Oh.
QP and then PR. They're the exact same thing. Yep. Yes, ma'am. Yes, sir.
Is that like
That's it.
for like the last time?
Like that's. I'm going to give you the assignment at this point.
Okay.
Yes, ma'am. Yes, sir. So we're going to. Okay. These are both going to be the same length. Because it tells me that they're. Yep, you're saying both those equal to each other.
Wait. 8 is trippy.
8?
Yeah.
It's just like the very first ones we did.
But like it's like a degree.
But again, look at the chords that she's saying.
Yeah.
You just plug it in.
Oh, I have to plug it back in. Yeah,
My
that's right.
You're probably making way too hard.
Yeah.
That's what the actual is.
Oh, I was looking at the little. Okay.
Yes, ma'am. Where you gotta go? Super, you got it. Crushed it. Love it. All right, this last one, you guys got it. Plug that stuff in. You should add x equaled 3. Plugged it back in for PQ. Your length should have been 9. Okay, homework tonight. 8 through 14 even. 16 through 19, all 22 and 23. I'm going to let you know right now, numbers 17 and 19, you have to use that Pythagorean theorem sort of thing. Okay? Otherwise, you are on your way.